Okay, assalamu alaikum everybody. Before I started my presentation, I would like to express my gratitude to OMICS 2014, Earth Science and Climate Change. And I'm glad to share this study with you, which is derived relations between geoelectric and hydraulic parameters in Barabasin, Central Sudan. What this hydrogeophysics study do with climate change? It is indirect. Can I move?
Yeah.
Okay. Okay. Because climate change is globally, and either is warming or cooling. So Africa is not isolated. So in Sudan, we are affecting and witnessing several phenomena. Especially for the last 2 years, we are having snowing in northern Kordofan, where the study area, and we have long fall season when it should start the winter. So I think we are not isolated from global changing in climate. So this hydrophysical study is to manage the natural resources in Central Sudan Barabasin. And why Barabasin? Barabasin, when we consider the natural resources in Sudan, exporting animals, animal production. Okay.
Sorry, I apologize.
Okay. Why we are using? Why we are studying Barabasin? Barabasin and.
Hold it to your mouth. Yeah, like a singer.
I prefer that one. Okay, this is better. Type. Barabasin in Central Sudan, NorthKordofan State. Why we are choosing this? Because when we are considering the natural resources in whole Sudan, we are Barabasin is concerned. It's export center for animal grazing, growing crops, and groundwater resources, which is not a problem for till now in Barabasin. But the location of Barabasin in NorthKordofan State is adjacent eastern part of Darfur. Northern Darfur. And many, as you know, Darfur is a vulnerable area. I've been there in 2009, 2010. So many displaced people, they are moving and they are welcome in Northern Kordofan State. But they are sharing them the natural resources, the groundwater. So we have to plan or to look forward to manage and continue or prolong the use of groundwater in this area. Another thing that 70% of wells or drilling wells that is used for drinking, domestic use, agriculture, whatever, is drilled by organization, UNESCO, NGOs, and unfortunately 3 to 4 wells out of 10 are successful. So this kind of wasting money and limited budget. So we need to find a method which is cheaper, reliable, and produce groundwater new targets for drilling than other expensive like pumping well itself. So this will be the objective. The presentation will come through a brief introduction, main objectives of the study, which I explained already. The study area, physiography, geology, hydrogeology of the area. Then we come to the basis of the method of using geoelectric to estimate hydraulic parameter for the aquifers zone in Barabasin, and finally with result and interpretation. The hydraulic parameters of any aquifer. We are talking about hydraulic conductivity, if you are concerned with that, transmissivity, specific yield, and all these will control us to quantitative prediction of how much pumping or recharging we are taking for those people. So the better estimation for hydraulic parameter and transmissivity and so on is better estimated with good accuracy by pumping test. But pumping test is time consuming and expensive. So we have to use something or a method that we already used it before doing the pumping test. It's the geoelectric measurement or sounding measurement. The idea of this relation between hydraulic and and geoelectric barometer started in the 1950s. And they found the relation between the grain size of the aquifer zone and the hydraulic parameters and the porosity of the aquifer. Till we came to Singa in 1980-85. They found that there is a real relation if we have the perfect grain size, which allow the transmission of current and at the same time transmission of groundwater. That means the study is not new. It has been applied in different areas, but not in Sudan. So now we are trying to apply it in Sudan widely in heterogeneous environment like ours in Barabasin. So in the present study, we are going to derive a general functional relation between surface resistivity from surface resistivity sounding and the hydraulic parameter estimated from the pumping test already drilled in the area. This is the study area. The ground surface, this is a digital elevation model for the Barabasin, which shows that it slopes to the east and northeast towards the White Nile. And you know the White Nile is a tributary, the second one with the Blue Nile Basin, and they all conjected in Khartoum and forward as a river Nile. So this is the slope, gently. And the soil, this physiography of the area, the soil is divided in 3 types. We have sand dunes, which is unconsolidated, cannot store water, and very poor in organic material and minerals. And we have also 2 types of clay, light clay, heavy clay, and heavy clay especially with the course of the streams, water streams. The geology, how this area came to the surface. Well, after the Precambrian basement, the area is covered by shallow seas forming now formation, which is sandy. But then it is subjected to kind of erosion, and then again continental seas. And this is the most important event happened to Sudan, and especially in Barabasin and other areas in Sudan, because this kind of depositioning of very horizontal sandy layer, which we call Cretaceous Nubian sandstone formation, which is considered as a main groundwater aquifer in many areas in Sudan, including Barabasin. Then African rift system appear with volcanics, and creating that Central African shear zone extend from Western Africa till western part of the Red Sea. And this kind of shearing, many grabens created. One of these grabens is Barabasin, Bagara Basin, and between these grabens we also have troughs. Many people, many geologists studied the geology, hydrogeology, potential for oil exploration in Barabasin, in northern Kordofan. This is the location of the area in the red box, the Barabasin, this solid black, and this is the Central African shear zone, and the hatch location are the troughs or the shallow basement. This is lithostratigraphy sequence, as I mentioned now. Started from Paleozoic, from basement, then Paleozoic now formation, our target, Cretaceous Nubian sandstone, till the recent superficial deposit. This is also a geological map of the area. This is important. This is a digital basement terrain model, the depth to the basement in the whole region. And it's very clear that the reddish one is the deepest basement, which means this is the location of the basins. And due to this Central African shear zone, we had 2 types. I don't want to come to structure, but we have 2 types of lineaments. The northeastern along the African shear zone, and the northwestern, which we call it extensional and release fractures. And this divided the whole Barabasin into 4 sub-basins: Al-Bashiri Basin, Umbrawaba Basin to the west, and Hashaba or Majaja Basin to the east. So we are taking the western part because there are not enough bombing test well data in the eastern part. So hydrogeology of the area. The area is the rainfall range between 200 to 40 millimeters the annual, and it's increasing downwards or to the south. The climate between semi-dry or semi-arid to poor savanna to the south too. Okay, now we are coming to our method. Our method to extract this geoelectrical measurements which are already done. In the area by IFAD, International Fund for Agriculture Development in 2004, and WEST, it is Water Environmental Section, belong to the Groundwater Authority in Sudan. They did bombing test. So we have both at the same time in 2004. The relation is how to get the hydraulic parameters considering the Darcy law. I think you all know the Darcy law, which is the Q equal minus the discharge is equal minus because it's mathematical relation. The K is a constant hydraulic conductivity, and H is a gradient, and R is the distance of the water flow. While the Ohm law is J, is current density, sigma is electrical conductivity, and V is the potential, and R is the distance for this current. So we have to relate these two equations, and to find for homogeneous isotropic media, Laplace equations satisfy these two equations. I don't want to come through it, but it looks like they look like each other. We have the same R, we have the same distance, the same bores can accept the flowing of current and the flowing of water. Then we come to one point. Why we are coming to one point when we were talking about 2 dimension? Now we are coming to 1 dimension because wells data is 1 dimension data, and VES, vertical electrical sounding, is also 1 dimension data. So both will be solved for point current equation. Okay, what that has to do with hydraulic conductivity? The transmissivity of the aquifer is the hydraulic conductivity product times the thickness of this aquifer. And from that, we can also find out the hydraulic gradient with the discharge, which is Q. And K is the hydraulic conductivity, which is constant for the aquifer. B is the thickness. Okay, this is simply the way we conduct the vertical electrical sounding. We have Schlumberger different arrays type. Schlumberger is one of them, where we have 2 different electrodes for current, 2 electrodes for potential. We send special current. We have cycling of sending this current and receive the resistivity, which is not true resistivity. And then we have to process that in some software or manually by standard care to get for each layer beneath the vertical electrical sounding, we have the layer and the thickness of this layer and the true resistivity for this layer. So we have a set of several vessels. Each one has a layer and the electrical resistivity for the true resistivity and the thickness. Okay, this is the data. In the area is covered by more than 150 vessels, but only Al-Bashiri and Barabasin Basin are covered by 37. The rest is somewhere else, and we are restricted to this area because we have bombing tests. We have about 17 wells bombing test data in this area. So from resistivity alone, we can have this line like AB, cross section, geoelectric section, which is calibration or similar to a geological section, and we superimpose that with information from the wells, and the black in each well is a filter where the filter is installed. Finally, 2 minutes. Okay. Finally, this is the lithology of the area based on geoelectric, and this is the method where we can divide for each aquifer resistivity 2 components, vertical and horizontal. We'll disregard the vertical, we'll concentrate with the horizontal component and compare it with the hydraulic conductivity. This is just to make it simple. And this is a formation factor, which is also a parameter related to the aquifer zone and the porosity and resistivity as well. So from these, we managed to calculate the transmissivity from this geoelectric and to calculate the hydraulic conductivity. So we have both hydraulic conductivity, transmissivity from the resistivity data and hydraulic conductivity, transmissivity for this aquifer from the pumping test data. And this is the tables of the data. And this is how data looks like, linear power relationships. This is the data also. All parameters obtained from pumping well test or from the geoelectric. And finally, the calculated hydraulic conductivity, the calculated transmissivity from resistivity data are, they create a contour map, superimpose the digital basement model. And this is finally the calculated hydraulic parameters, either from testing pumping well data or derived calculation, like what we did now. As you see, it is almost similar or almost the same. By this study, we can reduce the cost of drilling wells. And the next plan is to take this study and put it to take these parameters and use it in the eastern part where we don't have already pumping tests and decide new location for drilling new wells in the area. And so that the derivation of this relation between hydraulic geoelectric is successfully we're successful in this area, and now it is recommended in Sudan. And thank you.
Thank you very much. So, is there any question?
Thank you. Oh, sorry, this is up too loud. Can we turn this down? Thank you. This is very interesting. About 20 years ago, I used heat pulse flow meters to measure conductivity in single wells rather than putting in 3 or 4 wells to triangulate flow direction across sites. So you mentioned salinity at the beginning. What effect did you see, if any, on the results for an aquifer formation that would be less saline or more saline for the same type of soil, the same size soil grain? What's the impact of salinity on these resistivity readings?
Okay. Actually, we have two aquifers. I didn't mention the shallower part because the shallower, the deeper aquifer is the Nubian sandstone. The upper aquifer is Umrawaba aquifer, which is also sandy with intercalation with clay. But the problem with salinity comes from the overproduction, because in this region they drilled too many wells at the same time. So we have problems of salinity, increasing the salinity in concentration in the aquifer at that area, and depression cone. We got too much depression cone, which affect new production. So these wells will be dead in two years maybe. So this is the salinity problem. But for the upper part, the upper aquifer, which we didn't consider it here, we have salinity. Yes, saline lenses.
I have a small question.
Okay.
Did you compare your measurements with other available pedo transfers functions, or they are modeled, they are software to modulate pedo transfers and soil hydraulics? Did you compare your results with some like Rosetta or other models? Are you familiar with those?
No.
Are you familiar?
What kind of parameters?
Hydraulic conductivity.
No, I mean compared to which parameter? to compare this hydraulic parameter
Like
to?
if you have like texture and some other simple soil physics parameter, you can derive some
no,
of the.
no,
Okay.
this wasn't here. It wasn't compared to such parameters.
Okay.
Yeah.
Okay. Thank you very much.
Thank you.
We have a recognition for you.
Thank you.
Very
Thank you
good
so
job.
much. Thank you.